Ever wondered how cigarettes are actually made inside a factory, step by step, on an industrial scale? From a green plant growing in a field to a perfectly packed box rolling out of a high-speed production line, the process is far more complex than most people imagine. It involves agriculture, chemistry, precision engineering, automated robotics, and strict quality control systems working together continuously. Here is a detailed 1,500-word walkthrough of the complete cigarette manufacturing process. Tobacco cultivation and harvesting. The process begins on tobacco farms, where tobacco plants are grown for several months under carefully controlled agricultural conditions. Farmers select soil type, irrigation levels, fertilizers, and pest control methods to ensure the leaves develop the right chemical balance. Tobacco plants are usually harvested in stages rather than all at once. This is because leaves on the same plant mature at different times. The harvesting starts from the bottom leaves, which are exposed first to sunlight and mature earlier. Then the middle leaves are harvested, followed by the upper leaves, which are thicker and contain stronger flavor compounds. Each part of the plant has a different purpose. Lower leaves tend to be milder and burn faster. Middle leaves offer balanced flavor and nicotine content. Upper leaves are stronger, richer, and more aromatic. After harvesting, leaves are collected carefully to avoid damage because bruising can affect flavor during curing. Curing of tobacco leaves. Freshly harvested tobacco contains high moisture and is chemically unstable. It cannot be used directly. Curing is the process that transforms raw leaves into usable tobacco by drying them in controlled environments. There are 4 major curing methods. Flue curing. Leaves are hung in large barns where hot air circulates through pipes. The air does not come in direct contact with smoke or fire. This method produces bright yellow to golden brown leaves with higher sugar content. It is widely used for cigarette tobacco. Air curing. Leaves are hung in ventilated barns and allowed to dry naturally over several weeks. This produces darker leaves with lower sugar and higher nicotine concentration. Sun curing. Leaves are dried under direct sunlight. This method is common in regions producing oriental tobacco varieties. It results in thin, aromatic leaves. Fire curing. Leaves are exposed to smoke from slow-burning wood fires. This gives tobacco a strong smoky aroma and a darker color. During curing, moisture content reduces gradually. Chlorophyll breaks down. Chemical compounds stabilize. Color changes from green to yellow, brown, or dark brown. This stage can last from several days to several weeks, depending on the method used. Sorting, grading, and baling. Once curing is complete, tobacco leaves are sorted by trained workers and machines. Sorting is essential to ensure consistent quality in final products. Leaves are graded based on color consistency, texture and thickness, size and shape, presence of defects or damage. High-quality leaves are reserved for premium cigarette blends, while lower-grade leaves may be used in different tobacco products or reconstituted blends. After grading, leaves are compressed into large bales. These bales are wrapped tightly and transported to manufacturing facilities. Aging and fermentation. At the factory, tobacco is often stored for aging before processing begins. This aging period allows natural chemical reactions to continue inside the leaves. During aging, harsh compounds break down, flavor becomes smoother, aroma becomes more balanced, moisture levels stabilize. Some tobacco batches are aged for months or even years, depending on product requirements. Temperature and humidity are strictly controlled in storage warehouses to prevent spoilage or mold growth. Blending of tobacco. Blending is one of the most important and carefully guarded steps in cigarette production. It defines the taste and identity of the final product. Different types of tobacco are combined, such as Virginia tobacco for natural sweetness, burley tobacco for strength and body, Oriental tobacco for aroma and complexity. In addition to raw tobacco, manufacturers may add controlled flavoring agents such as sugar-based solutions for a smoother taste, cocoa extracts for aroma enhancement, licorice for flavor balance, menthol for a cooling sensation, humectants to maintain moisture stability. Blending takes place inside large rotating drums that mix tobacco evenly. The goal is to create a consistent flavor profile so every cigarette tastes identical. Even small changes in blending ratios can significantly alter the final product. Stem removal and reconstitution. Tobacco leaves contain a central stem that is thick and does not burn efficiently. These stems are removed using automated machines. The separation process divides leaf lamina, soft, usable part; stems, hard, fibrous part. Some stems are processed further into reconstituted tobacco sheets. These sheets are created by grinding tobacco material, mixing it with binders, and forming uniform sheets that can be cut and reused in blends. Cutting and shredding. The clean tobacco leaves are then fed into high-speed cutting machines. These machines shred the leaves into very fine strands. The cutting process is extremely precise because uniform strand size ensures even burning, controls airflow through the cigarette, prevents clogging or loose tobacco fallout. If tobacco is cut too coarse, cigarettes may burn unevenly. If too fine, airflow becomes restricted. Therefore, machines are calibrated to achieve exact strand thickness. Moisture conditioning. After cutting, tobacco passes through conditioning chambers where moisture levels are adjusted carefully. Moisture is one of the most critical factors in cigarette production. If tobacco is too dry, cigarettes burn too quickly. Smoke becomes harsh. If too moist, cigarettes may not ignite properly. Mold risk increases during storage. Humidity-controlled air systems ensure tobacco remains within a narrow moisture range. Sensors continuously monitor conditions in real time. Cigarette paper preparation. Cigarette paper is specially designed paper that differs significantly from regular paper. It is engineered to burn at a controlled rate, maintain structural integrity during smoking, allow controlled airflow, produce consistent ash formation. Some papers contain microscopic perforations that help dilute smoke and regulate draw resistance. Large rolls of cigarette paper are loaded into production machines and fed continuously during manufacturing. High-speed cigarette manufacturing. This is the core production stage. Modern cigarette machines operate at extremely high speeds and can produce thousands of cigarettes per minute. The process works in a continuous flow. First, shredded tobacco is fed into a forming chamber where it is evenly distributed into a long cylindrical rod. This rod is wrapped with cigarette paper and sealed using adhesive. The machine then cuts the continuous rod into exact cigarette lengths. At this stage, diameter is controlled precisely. Weight is monitored constantly. Airflow resistance is measured. Rod density is regulated. Even minor deviations are corrected instantly by automated control systems. Filter production. Most modern cigarettes include filters designed to modify smoke intake. Filters are made primarily from cellulose acetate fibers, which are processed into a dense cylindrical structure. The production process includes fiber spinning and alignment, compression into rods, wrapping with filter paper, cutting into uniform filter segments. Some filters include additional features such as activated carbon layers for adsorption, flavor capsules that release taste when crushed, ventilation zones for airflow control, filter attachment process. Filters are attached to cigarette rods in another high-speed machine. A special tipping paper wraps around the connection between the filter and the tobacco rod. This ensures structural integrity and consistent appearance. Machines ensure perfect alignment between filter and rod, strong adhesion between components, uniform cigarette length, consistent filter placement. At the end of this stage, the cigarette is fully assembled. Quality control and inspection. Quality control is continuous throughout production, but final inspection is especially strict. Automated systems use cameras, sensors, and laser scanners to detect defects such as missing or damaged filters, loose tobacco ends, incorrect cigarette length, paper tears or imperfections, weight inconsistencies. Defective products are automatically removed from the production line. Additional laboratory testing may include burn rate analysis, smoke airflow resistance testing, moisture stability checks, chemical consistency verification. Only cigarettes that pass all tests move forward. Packaging process. Once approved, cigarettes are transferred to packaging machines. The packaging process includes several layers. First, cigarettes are grouped into fixed quantities, typically 20 per pack. They are aligned neatly in rows. Next, an inner foil layer is applied to preserve freshness and control moisture loss. After that, cardboard packaging is formed around the cigarettes using automated folding machines. The pack is sealed and labeled with branding, health warnings, and government tax stamps or tracking codes. Finally, packs are grouped into cartons, and cartons are packed into shipping cases. Storage and distribution. Finished products are stored in warehouses with controlled temperature and humidity conditions to maintain quality before distribution. From these warehouses, cigarettes are distributed through logistics networks that include trucks, shipping containers, and regional distribution centers. Products are then supplied to retailers across different regions and countries. The cigarette manufacturing process is a highly automated industrial system involving agriculture, chemical processing, precision cutting, high-speed machinery, and strict quality control. From raw tobacco leaves in the field to a finished product in a sealed pack, every stage is engineered for consistency, efficiency, and uniformity at a massive scale. What appears simple on the outside is actually the result of a complex global production chain operating continuously in factories around the world. If you want, I can next explain how cigarette filters work in detail, or how machines produce thousands per minute without stopping.